And would this say that dark matter is several particles? It's not just a single one? It's a tower of them?
Well, so the tower that I'm talking about turns out to be one particle, namely just graviton. Now you might say, wait a second, graviton is massless. But 3 plus 1 dimensional graviton is massless, but 4 plus 1 dimensional graviton is not massless because the graviton can have waves, oscillations in the other direction. This tower I'm talking about is nothing but oscillations of graviton. So it unifies gravity with dark matter. So dark matter is nothing but excitations of the graviton, which is why it's weakly interacting, because gravity is weakly interacting. So the dark matter becomes a tower of these graviton, which is weakly interacting anyhow. So it unifies dark matter with graviton and dark energy into one package.
Does this then have a name, like a separate
dark
theory?
Dimension. We call this dark dimension scenario. Yes. So dark dimension scenario is a scenario that there's one extra dimension opening up. And this is coming from this swampland idea I just told you. So there are a few other predictions that this makes about cosmology, in particular about axion physics and other things that are potentially also very interesting. And ultimately, it's an answer to a kind of an answer to a question that Dirac was asking. Dirac had noticed that different scales in physics has bizarre relations by factors of 10 to the 30, 10 to the 20, 10 to the 40, these big numbers. And he was saying, it looks like they are not related by factors of 2 or 3. They are related like by powers. What is the reason for this? So in the context of swampland, we have actually seen exactly the reasoning for why they are powers. And more than that, we find things are given by powers of 1/12 of the cosmological constant. So things come in chunks of lambda to the 1/12.
Huh.
And that's about 10 to the minus 10. So you get 10 to the minus 10, 10 to the minus 20, 10 to the minus 30, etc. And these give you the different scales in physics. One of them gives you the higher dimensional Planck scale. The other one gives you the weak scale. Another one gives you the neutrino scale. Another one gives you the large scale of physics, the large size of the universe. So all of these scales fit into this hierarchical fashion given by the dark energy. So the dark energy gives you a unifying principle about all these different scales.
This dark dimension theory, when did it occur to you and your collaborators? Like, how long was the time
gradually
span?
developed. It gradually developed. So the distance conjecture was started around 2006.
Okay.
The fact that you go, but then we applied the distance conjecture to the case of cosmological constants in another paper. I think that was 2018. And then in a few years past, we tried to think about cosmological aspects of it. And then we gradually were going in the direction, and in the 2022, it led to the actual say, why not? Combining this gives you that. So the idea came gradually, but it could have been done much faster.
What do you think about De Sitter quantum gravity?
Well, quantum gravity, De Sitter seems to have a problem of stability. And so a lot of these ideas in the context of swampland seem to point towards the idea that De Sitter space with positive energy cannot be stable. Well, the question would be, okay, if they are not stable, what's the time scale of the instability? And what we think is that the time scale of the instability is itself set by De Sitter. That means it's what we call the Hubble scale. So, for example, if you take that in our universe, it suggests that the scale in which the universe will unwind, or the dark energy will unwind, is roughly the age of the universe, current universe. So that is kind of interesting because it will tell you that the dark energy has a time scale associated with it also. And we don't know if the recent observation of DESI, which the dark energy survey, which tried to see whether dark energy is constant or not, they seem to have some indication that dark energy is actually changing and decreasing with time in the same kind of time scale as one would naively think along the lines I'm talking about. So these kind of ideas tell you that dark energy is actually dynamical and actually evolving potentially in time. It's certainly not stable. So quantum gravity of De Sitter should not exist in the sense of a complete De Sitter. It could be just patches, short time maybe, but not in the long term. In the long term, it will decay.
So does that mean that our universe, which is De Sitter, will decay?
Yes. Correct. We expect our universe not to be stable. In fact, I think every string theorist believes that we just don't know exactly the time scale. The arguments emanating from swampland suggest that the time scale is given by the Hubble, which is roughly the age of the current universe. So that's the kind of a time scale.
You're saying that the age of the universe is the expected age of a De Sitter universe
Yes.
to collapse.
Up to a log factor, which I didn't tell you about. So in other words, it's age up to a logarithmic correction. So if you want to get the upper bound, we think it's like 2 or 3 trillion years.
Okay.
So it's upper bound. We don't think it's going to be more than 2 or 3 trillion years. This is an idea from swampland, which has less of an evidence because we don't have examples of De Sitter from string theory. So we have extrapolated what we know to get this. It's what's called the Transplanckian censorship conjecture. So this is one of the things that we are trying to gather more evidence for.
Mm-hmm.
Check it to see if it's correct, if it's not correct, and so on. But the idea suggests that there's this upper bound. But at any rate, all the examples we know in the context of string theory, which has dark energy, is always unstable. The question is how unstable they are, and that's what we are trying to figure out.
Why did you call that a problem? Because when I asked, just to reiterate, okay, what do you think about De Sitter quantum gravity? You said the problem is that it's unstable. Why is that a problem?
Yeah, because De Sitter, when people talk about De Sitter, they mean everlasting De Sitter. If you're just having a piece of De Sitter, then that's different. So in other words, there's a time. De Sitter has a time axis.
Okay.
So if you take the curvature or the scale of De Sitter and extrapolate in time, we're saying it won't last. So therefore, it's not De Sitter. You call it De Sitter or not, this becomes ambiguous.
So, Professor, to end, I want to know, what is a mystery that you think about on a daily basis?
Well, trying to see what we can find theoretically to check this idea of dark dimension right now. These days, I'm mostly consumed about trying to understand how we can confront string theory with reality. I'm hoping that in my lifetime, there will be experiments which will hopefully show us how string theory works in real world.
Yes, you said that many of your colleagues, not all of them, but many of them may have gone too abstract or gone too in the way of forgetting about this universe, and you're trying to bring them back with the swampland program or the weak gravity conjecture in particular. So can you expand more on that? What is this delineation between people who don't have a tether on physical reality, though they think they're studying physics? It's called theoretical physics.
No. I wouldn't say they don't have tether on physical reality. I think they think we don't have enough tools to study physical reality. I think they're under that impression. They think that's unapproachable right now with our techniques. So let's do abstract stuff for which our techniques might apply. That's their mindset. And I disagree with that mentality. I think we do have a number of ideas and techniques which does apply to our universe, and that's our difference. Otherwise, I don't think they're untethered to reality. They are. They just don't think that we do have enough of the tools.
So it's like a jigsaw puzzle, and you feel like we have the pieces already to put it together.
They say, don't waste it. We don't have. Exactly. That's the right way of saying it. I think we have enough of the jigsaw pieces in the place to figure out some of the rest that are crucial.
Uh-huh. And last question. At what time did we have enough of these pieces of the jigsaw? Like, what was the last piece that you're like, okay, from this point, we had enough to infer? If we were only clever enough, I mean, we have more mathematical tools now, but physically speaking, the experimental results were enough to allow us to infer the rest of the picture.
Well, the dark dimension is when I got convinced that we may have a chance, because that was a scale which was coming from the relation of dark energy with a particular physical scale that we can actually see in our universe, was motivated by abstract principles of string theory. So this connection that one thing leads to this concrete thing, like, wow, of course there's a very extremely tuned parameter in our universe, the dark energy. Why don't we even apply it? It was kind of daring to say, well, there's a tower. Where's that tower? Nobody saw this tower. And suddenly you remember that in two problems always come together. Problems come in pairs. And the two problems were, one is, what is dark matter? And the other was, what does this tower have to do with anything?
Yes, that's super interesting to me, because dark matter and dark energy were always misnomers to me, because they don't a priori have anything to do with one another. But then in the popular press, they said they're both dark, and so most people think there's some association, but you're actually concretizing that.
Yes, we are saying they are related. They are unified into one object, into this dark dimension. The existence of this large length, micron scale length, relatively large, is the manifestation of dark energy. And the long wavelength of gravitons on them is the dark matter. So the tower of light dark matter gets related to the size, which is set by the dark energy. So dark energy and dark matter get related. The mass of the dark matter gets pegged to the value of dark energy.
If you enjoyed this toe clipping, then the full video is linked in the description. You should also sign up for Toe Mail, which is again in the description and the pinned comment. You'll receive immediate access to all exclusive updates from the Theories of Everything podcast. It also helps me communicate directly with the core toe community. You'll also receive my top 10 toes. Think of it as the intellectual version of Quentin Tarantino's Obsession.